this computer. Oh, okay, hopefully don't miss much. Okay, yeah, I'm recording right now. Okay, so then, and then if I write it this, if I'm trying to working on this guy right here, okay, so normally we will write this as I minus x bar, then plus x bar, then minus theta 0, right here, okay? The reason I want to write here is I do want to create a new term right here, okay? Then plus, I have space, yes, I have space, so let's keep writing. Okay, so right here, I do have plus 2 summation I from 1 to n, xi minus x bar times x bar minus theta 0. Then right here is summation I from 1 to n, then x bar minus theta, then taking square. Nothing but a plus b squared, then a squared plus 2ab plus b squared x. Okay. The reason for that is I'm looking for this guy to cancel out with this guy. Okay, to simplify. Okay, and then what's this then? Okay, you see that before actually. Okay, this guy eventually is 0. What's 0? So let me open up something. Let me maybe writing down somewhere. What is guy 0? This guy basically is what? This guy basically is 2 times x bar minus theta 0. Then summation I from 1 to n, then xi minus x bar right here, right? This guy doesn't have I, so you can pull that out right here, okay? And then what's this guy? This guy nothing but 0. What's 0? Because summation I from 1 to n, then xi, then minus x bar is what it means. Then nothing, this guy nothing but what? Summation I from 1 to n, xi, then minus summation I from 1 to n, then xi then. That means nx bar actually nothing but summation xi. So that means this guy is 0. Okay, this guy 0. Okay, and this guy right here, I can first write as n times x bar minus theta 0 then square, because there's no I inside summation. I can pull that out, then that means I have n times that single guy. Okay, good. So then to simplify this, then I don't have space. I'm going to use another one right here. Okay. So that means eventually their lambda x right here. Okay. P2. Okay. So then their lambda x right here is what? Exponential minus, okay? Pardon me, right this. You should be able to see what happens if you check the previous slides. Then minus, I think, summation I from 1 to n, then xi minus theta 0. Maybe I mess up, just thinking about, right, theta first, then x bar later. Okay, theta first. So theta first, theta 0 first, then xi right here, okay? So theta 0 first, then x bar square later on. Okay, so be careful about the brackets. Okay, I think it's good. So that means, okay, I can actually cancel out a bunch of guys if I really writing down I from 1 to n, then xi minus x bar square, then plus n x bar minus theta 0, then square, then minus summation I from 1 to n, xi minus x bar, then square right here. Okay, so this guy could cancel out. That's what I'm looking for. That eventually your LRT is minus half, then times n, and right here, then x bar minus theta 0, then square. Okay, good. Then you finish deriving your LRT, lambda x. Okay, you could feel okay to claim that as long as lambda x is smaller than c, some cutoff, I'm going to reject the null hypothesis. Okay, but the point is, what c is? Okay, what's the cutoff? And I said, yeah, using alpha to find cutoff, right? Definition is of type 1 error is what? Probability lambda x smaller than c. Okay, good. Again, it's if I do know about lambda x, follow what distribution, f or f, either way. As long as I know about lambda x, follow what distribution, then I can using equal to alpha, again right here. If I do know that what is, I can basically using something like this to find c. Because I do know alpha, right? For example, if lambda x actually follow normality, if follow normality, okay? Say this guy right here, right? So hold on, right here, right? This is c, this is alpha, right? So that means I do know what, if I do know this is normality, if I don't know this normality, then this is alpha. This guy nothing but what? Z alpha. Then C is Z alpha. Got it? But the point is, okay, because it's not going to be normality, so I'm taking this out. Okay. Look at this lambda x right here. Do you know what distribution it is? I don't know, actually. It's hard for me to derive in this. Okay. And, or saying that is there's no common distribution you could use to talk about the PDF or CDF of lambda x. Okay. Then here comes the equivalent region to play. Look at this. So let me see. Okay. Say if you do have that lambda x right here. Okay. This is my lambda x. Lambda x. Okay. Lambda x. Okay. And then if you really pick up like MLE right here, for example, x bar right here is MLE right here. Okay. Then x1, x yourself. If I want to draw a function, a graph between lambda x and the x bar, what it would look like. Okay. Then you do need to learn about how to analyze the function analytically. For example, right here, looking at this, okay, this is x bar, function of x bar right here. Okay, this is quadratic function right here. And then you have minus term right here. What does that tell you? This guy is actually a concave function of lambda x. Okay, for example, it's you will find out something, it's going to be minimized at theta 0. Okay, if you plug in x bar, if you plug in dig here, okay, let me take out something. If you plug in x bar right here as theta 0, what happens? Theta 0 cancel out, everything 0, exponential 0 is what? 1. Right here. Okay, good. And then imagine if you don't know about the concave function, well, it's okay. So imagine what happened when x bar getting bigger. If x bar getting bigger, the whole thing getting bigger, right? Whole thing getting bigger. but you do a minus term right here. That means the whole lambda x what? Getting smaller. Getting smaller. So that means when x bar getting bigger, the whole lambda x getting smaller. Okay, good. Likewise, it's if x bar getting smaller, x bar getting smaller, x bar getting smaller. Okay, the whole thing actually getting bigger because it's quadratic, because it's square right here. Okay, again, it's whole thing getting bigger. Must turn right here. Lambda is getting smaller. That means right here. Also, a decreasing function as well. When x bar getting smaller, that means this is a concave function. Okay, of x bar. What's important? That's very important because of this. Okay, because of we are talking about I have choosing lambda x right here smaller than c. Right? Good. Then this is actually my rejection region, right? Or critical region, right? Lambda x smaller than c. Right here. Okay. Say if lambda x and x bar is actually a quadratic function like this guy right here, which means what? Which means whenever lambda x more than c, the x bar right here, let me use dots. Your x bar right here, okay? I'm going to call this guy as a C1 star. This guy is a C2 star, okay? Whenever lambda x smaller than c, actually mapping to the x square x-axis is what? Your x bar going to bigger than c2 prime or x bar going to smaller than c1 prime. Okay? This is very important. You do need to try to learn from this is how do I find that equivalent region? Why I can actually lambda x smaller than c actually equivalent to another test region is what? Your x bar bigger than C2 star or x bar smaller than C1 star. It's okay, good. I will leave this to you for 5 seconds. Do you guys have any question on this about equivalent region? You do need to know how to find it in LRT. Okay? Otherwise, you cannot moving forward. You cannot move forward on this equivalent region. Okay? Again, it's lambda x smaller than c, map into this line, and then that means x bar bigger than c star, c2 star, or x bar smaller than c1 star. Why is that so critical? You will see what happened. Okay. So like I said, it's because we could write your test region lambda x. Sorry about that. I want to make sure everything is perfect. So because I do know lambda x smaller than c is equivalent to r star is x bar smaller than c1 star or x bar bigger than c2 star. Then I can using that say type 1 error alpha supremum theta belongs to theta not probability of lambda x smaller than c. Why is that important? Because I can write this as a supremum theta belongs to theta not probability of x bar smaller than c1 star or x bar bigger than c2 star. It's okay. Then what's important? That's important because I do know what lambda, I do know what x bar follows right here. X bar follows right here. Okay, because X1 to Xn is normality, I do know X bar follow normality as well. Okay, good. And then how do I write this then? Okay, first of all, I do write supremum every time. But right now in this case, your null space is nothing but single point. Again, good for you, supremum, only single points. That means theta, nothing but theta now in null space. So I can write X bar smaller than C1 star, or X bar bigger than C2 star. Okay? In the probability, O means what? O means plus. That means I can write X bar smaller than C1 star, then plus probability of X bar bigger than C2 star. Okay? Then, just gonna say that 0. Then I do know this plus two probabilities equals to alpha. Okay? Conventionally, we can write this. X bar smaller than C1 star, then equals alpha over 2, then probability theta 0, X bar bigger than C2 star equals alpha 2. You can divide it by alpha equally in a half. But, I mean, also, you could also do this. If you want to be really, really picky, you could write it. I'm going to write this guy is alpha 1. Okay? Then this guy is alpha 2. Then making that such that alpha 1 plus alpha 2 equals alpha. You could do that as well. It's totally fine. But I'm trying to be simplify everything as easy as possible. Okay? So I'm going to divide it by half and half. Okay? Good. So then, if you allow me to do so, okay, then what does that mean then? That means I can working on this and working on this to find C1 star and C2 star. Okay, see how I can work it. See how I work on it. Then C1 star, right? Then equals to what? So because theta is theta now right now, so then I can X bar minus theta now divided by what? Divided by 1 over square root of n. And then smaller than C1 star minus theta 0 by 1 over n. Why do I want to do that? I want to do that is because theta is theta now right now. I do know the whole right-hand side of random variable what? Follow normal 0, 1 edge. How do I know that? Remember x1 dot 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 to xn, follow normal 0, 1. Our original, our initial example. That means X bar follow what? Follow normal theta again. It's 1 over n. Okay? So far, you need to know that already. Okay, this. Okay, you got to know this already. Okay, then because of this, I have my X bar right here, minus the true theta. This is true theta right now, because under null space, this is true theta right now, a theta now. Then divided by the standard deviation right here, then become normalized, become normal 0, 1. Okay. Then, because that guy is normal 0, 1, then you do know what that means. Because this guy actually normal 0, 1, okay? Then smaller than something right here. Smaller than something, right? This guy is smaller than something. This is that something right here, okay? The probability smaller than that thing is alpha over 2. So that means this guy, this area is alpha over 2. Okay? If that area is alpha over 2, what does that mean? That means this quantile right here is z alpha over 2. That means what? That means your C1 star minus theta 0 divided by 1 of square root n right here equals what? Equals to z alpha over 2x. That exactly give you C1 star equals to theta 0, then plus 1 divided root n, then z alpha over 2. Okay, you see that? How do I find C1 star? Okay, likewise, you can find C2 star because you do have probability theta 0 right here, x bar bigger than C2 star. Okay, so let me jump. So I'm not going to explain again this. What does that mean by this? Bigger than C2 star minus theta 0 divided by 1 over right here. Okay, and again, you do know this guy right here is normal 0, 1, normal 0, 1, and again, normal 0, 1 bigger than something. Okay, right here, this guy is what? Normal 0, 1 bigger than something right here is alpha over 2. Then this guy right here is alpha over 2. Then what does that mean? This quantile is what? Z1 minus alpha over 2. I was using quantile as your left-hand side probability. So this guy would be 1 minus alpha over 2x. Okay? So it means that give me what? That give me C2 star. Oh, okay. I lose my power. Hold on a little bit. Okay, good. So that means what? That means C2 star minus theta 0 divided by square root of n is what? Equals to Z1 minus alpha over 2x. They also give me C2 star is theta 0, then plus Z1 minus alpha over 2, then 1 over n x. Okay? So that means at deriving C1 star, at deriving C2 star. So that means the whole set means what? The whole set means eventually the region, okay, although I don't know about what C is, it's fine. I do know about another equivalent region is what? X bar, okay, bigger than, let me see, I actually forget about which one is bigger. I guess it's theta 0 plus Z. They're going back to check it. Okay. Okay. So that means X bar bigger than C2 star. X bar bigger than C2 star. C2 star is here. So that means, okay. Just memorize it. Then, okay. Okay. This guy is 1 over this guy and 1 over square root n. Or right here, or x bar smaller than theta 0 minus z alpha 2 1 over n x. Okay, so it means the right hand side of this guy right here is an LRT. Okay, so looking at this whole thing right here, what do we call it? Okay, we call it one sample z test. Okay, which means in your undergraduate study, you possibly looking at the hypothesis testing right here. If you look at testing right here, okay, null hypothesis, looking at testing right here, your null hypothesis theta 0, your alternative theta doesn't equal theta 0. This theta square known. Okay, without any derivation from your undergraduate study, you possibly know that I'm going to using z test because this guy is known number. okay? And then possibly you won't be hesitant writing down like this guy, one simple z-test, okay? Then the LRT right here, exactly providing you some general way to deriving the z-test is, okay? Then you will see that a lot, you see that coming in minutes, okay? A lot of tests is actually an LRT test, okay? I can keep showing you if we have time. If we have a chance, for example, in midterm practice, you might see other situation asking to derive LRT, then but it ends up it's some common test we normally see. Okay, sounds good? Okay, this is based on example right here. And then another example, I want to keep doing this. Okay, hope you don't mind, because this is really important for your midterm number 2. It's how to derive LRT under different scenario. Okay, the principle is the same. Then you just need to be patient, need to do derivation very carefully. For example, if I do have x1 to xn, okay, basically without exponential, okay, but a little bit shifted because I do minus theta right here, okay. It's not like usually exponential 1. Right here is exponential 1, but shifted about theta, okay. Then x bigger than theta is that one. If x smaller than theta, it's 0, okay. Good. And then if in that case, if I want to do x1 to xn like that way, okay, like this way right here, like this way right here, okay, then of course I don't do testing. Make sure that what testing you are dealing with. You are dealing with null hypothesis theta, so theta 0, then versus alternative is what? Theta bigger than theta 0 right here. Okay, then what is LRT? Again, every time people want to derive LRT, you write down definition. You got points, trust me. Okay, good, write down definition. Okay, then the next step is deriving about your LRT. It's numerator, denominator. Okay, then denominator is always easy, right? Why is easy? It's because nothing but MLE. Okay, then what's MLE then? Right here for theta. Okay, then you note down MLE right here. MLE right here. Nothing but 1, then product PDF, right? Product PDF right here. Product PDF. Then exponential, then minus xi minus theta right here. And then for don't forget indicator function, you do have what? Every xi got to be bigger than theta, otherwise it's 0. Okay, and then you see that multiple times already. Then this guy right here is what? This guy is exponential minus product, consecutive product on exponential become summation. And then right here is what? Right here, you know the drill, right? So every xi bigger than theta, I can just simply define as what? X1 bigger than theta. Okay, so I do anticipate you know how to deriving MLE right here. Okay, now we're going to show you because it's very, very important with the number 2. I want to say it again. Hopefully you don't mind. I say that. I keep saying so. Okay. How do I derive MLE? You need to look at this function first. You need to look at this function first. Then ask yourself, is that increasing function or decreasing function of theta? Keep in mind, function of theta. Function of theta. Look at this. Increasing function or decreasing function of theta? Okay, the answer is increasing function. What is increasing function? It's because This is theta. This is minus, but this is minus as well. Minus become plus. Okay, so that means as long as theta getting bigger, the whole function getting bigger, inclusive function of theta. Okay, but in the meantime, this guy also function of theta as well. That means you pin down what x1 is. Okay, then look at this guy right here, function of theta. Theta smaller than x1, that's a value. That means theta smaller than x1, that's a value. Okay, then theta, if theta bigger than x1, what happens? The whole thing becomes 0. Okay, so that means you need to taking out. Well, I can, yeah, taking out. Okay, right here. That means whole function is increasing function until x1, then going down becomes 0. Okay, then look at this picture. Exactly told you that what MLE what is what. Nothing but x1. Good. Okay, so it means MLE x1. So that means this guy right here is what? L then x1 is in the denominator. Okay, I just know this to out these, so let me take it out. Otherwise, too misleading right here. Okay, but keep in mind, denominator nothing but right here. x1 right here. Okay, then you're working on the numerator. A little bit complicated. Why a little complicated? Imagine this. I want to keep this graph right here though. So, okay, let me see how I do it. Maybe just open up a new thing. Okay, so right here. So in the numerator, okay, the thing's more complicated because what? Because remember what your null space is. Your null space going to back this, going to back to this is what? It's theta smaller than theta 0. Okay, so it's not a single point anymore. Okay, there are multiple points right here in your null space. Null space. Okay. So yes. Question? No? Okay. Okay, good. So that means you need to talk about it. Where does that supremum occur? Okay. Compare original normal case. Previous cases, null space, only single points. No discussion. Plug in. Right here, you have so many points in null space. You do need to talk about it. Okay? Good. The reason for that is, okay, I just show you right here. L theta, then theta. Remember, talk about saying that this is increasing function until something, until x1, then coming down to become 0. Okay. So imagine this. Because your null space is theta, small than theta 0. It all depends on where theta 0 is. See, if I have theta 0 right here, okay? If I have theta 0 right here, okay? Then this guy right here become my null spaces. Okay? Then looking at this Laplace function, look at this null space. Which one actually maximize my Laplace function? Nothing but x1 again. Okay? So that means I would say this guy right here. If the theta 0 actually bigger than x1, okay, then the maximizer of Laplace function will be also x1 as well. Okay, but what happened if you theta not? Oh, okay, go up. Okay, what if your theta not actually is here? Theta not. Okay, if your theta not is here, your null space only happens here only. you need to find the maximizer only null space. That means you don't actually count that every one of them. Your Lagrange function eventually would only look like this, increasing function until this guy right here. This is null space. Then look at the picture. Which one is MLE? This guy is my MLE. The reason why if your theta not smaller than x1, what's MLE? Is theta 0. They are different. Okay, good. Then combine together, that means because my numerator is always x1. Okay, but my denominator is actually depending on where the theta naught is. If theta naught bigger than x1, then this guy x1, then eventually cancel out, then become 1 right here. Okay, then if theta naught smaller than x1, then your LRT become what? Then x1 is. Okay, good, great. Okay, so then you can actually write it more clearly. It's what your L theta, because this is 1, nothing to express. Then x1 is right here. Okay, so I'm going to save it. Maybe P what? Okay, about what P is right here. Oh, P5. P5. Save. I don't want to know what. Okay, so this type of function. Okay. Okay, I cannot paste and then so okay, I need to memorize it. So okay, so this guy exponential minus summation I from 1 to n xi minus theta 0 indicate the function, then x1 bigger than theta now. Okay, this is the numerator, and denominator will be what? Exponential minus summation I from 1 to n, then xi minus x1. Then indicator function, this guy always 1, so nothing actually to write. And then eventually is what? This guy right here is. I'm going to jump a little bit because I don't have time. So then right here is what? Summation. This guy cancel out, I can imagine. And then eventually become exponential. Then x1 and theta now minus x1. Okay, let's do that. Or minus x1 plus theta now. How about that? Theta now, then minus x1 is. Then indicator function of x1 bigger than theta now it's. Okay, good, great. So that means you are finding LRT. Again, you could write down the likelihood function. But I'm sorry, write down the critical region. Right. Write down critical region. Critical region would be what? Lambda x smaller than c. Okay. Then again, this is lambda x right here. Of course, 1 right here. You later will show. You later will see that. Okay, lambda x. Again, ask yourself, do I know distribution of lambda x? Possibly not. But I can find equivalent region of R star using some easy statistics, especially MLE. MLE is what? X1. Then I'm going to find this guy is bigger than C star or X1 smaller than C star. I don't know which one. I'm going to decide the one of them. Okay, then that means I need to find that equivalent region of lambda x, then theta right here. Okay. Oh, no, it's not theta. It's x1. X1 right here. Okay. So look at lambda x right here. Lambda x right here told me that it's x1 smaller than theta 0. Theta 0 right here. Whenever x1 smaller than theta 0, the LRT is 1. This one right here. Right? X1 smaller than theta 0. Lambda x is 1. And then if x1 bigger than theta, right here, okay, x1 bigger than theta right here, and then this is my LRT statistics, then ask yourself, is this guy increasing or decreasing function of x1? Okay, because there's the minus term right here, the whole thing actually is what? Decreasing function of x1. It's okay. Then right now it's taking this out. I want to take this out. Okay. Right now it's you tell me, hey, I want to find something lambda x smaller than c. Okay. So lambda x smaller than c right here. Then which one is my equivalent region? That means this guy right here, it's my equivalent. Let me using dots. Then this guy right here is my C star. Okay. And then lambda x smaller than c map into this line. This line map into this region is my critical region. That means my equivalent region using x1 is what? Lambda x1 bigger than c star is. Okay. So any question on this? I want to make sure that you guys feel comfortable finding equivalent region.
Could you explain one more time why you know that it's the x1 greater than or equal to c star?
So did you see this graph right here?
Mm-hmm.
Okay. So I said LRT got to be lambda x smaller than c, right? Okay. Yeah. Then look at its function. Okay. Every point smaller than c right here, mapping to this point right here.
Okay, I see. Yeah.
You see that?
Mm-hmm.
Okay, great. So that means if I can claim lambda x smaller than c, equivalently, I claim x1 bigger than c star. Okay, good.
Yep.
Yep. Thank you. Bad news is we haven't finished yet, but we are always end of class. 10 minutes to go. Okay. Why I say we haven't finished yet? Because even though I do know x1 bigger than c star, but what is a c star? How do I find it? The same drill. How do I find it? Using alpha. Again, write down definition. Okay, good. And then right here is what? You do need to find out this supremum. Null space. Null space is theta smaller, theta not. Okay. Then probability of x1 bigger than c star is. Okay, good. Then how do I find it then? Right here. First of all, I do know about this, right? This is probability of x1 bigger than c star is, which means that this is what? X1 bigger than c star. That means everyone is bigger than c star. Okay, you could use that to find the you could use that to find a probability of a C star is. Okay, good. Because I don't have time, so let me jump a little bit. I do. Let me see. Let me see. Do I have anything to tell me that it's what the probability is? No. So I guess what I have to do is just deriving it right here. Then hopefully I can derive it in 10 minutes. Let me imagine that. So basically is x1 bigger than C star with power n. Okay. Good. So then by that PDF, probability of x1 bigger than C star equals to what? C star up to the range of that is, I think, par infinity. Then the PDF would be exponential minus x1 minus theta, then dx. Okay, so that means this guy equals to what? Exponential minus x minus c, right? Minus theta, right? Hopefully I do that correctly. Minus dx, then minus 1, I think. Okay? So I think by the end of the day, it's got to be exponential minus c star minus theta right here. I think so. Yep, switch, then plug in, yes. Okay, good. So that means, okay, it's not hard to derive, so I don't take much of my time, minus C star minus theta right here. Okay, but point is, critical one is, you do need to deriving supremum over theta right here. Okay, so that means, again, I don't know it's annoying, I know it's annoying, but again, going to what is function, increasing function or decreasing function of their function is. So making sense? Because you need to find supremum, right? You need to find that single point, maximize the whole function. Okay? So easy way to do it is asking yourself, what if theta getting bigger? Okay? So if theta getting bigger, imagine this, minus 10 right here. Okay? That means theta getting bigger, the whole function getting bigger. If that's the case, then you're trying to find supremum. That means this is increasing function, right? It's a function right here. Okay, theta 0. Increasing function, right? When theta getting bigger, whole function getting bigger. Then you will know that is the maximize is going to happen to what? The supremum or the supremum always happen to the theta naught. Okay, so it means the maximizer, the supremum happen in the theta naught. Okay, so that means eventually you can write down it's exponential minus C star minus theta naught. Then using that, you could find what C star is, because I can take in log on both ends minus C star, then plus theta 0. Then you will know that C star is what? Theta 0 minus log alpha. So it means even though eventually this is my critical region, okay? I don't know much about C, but I do know equivalently, I can write x1 bigger than theta 0 minus log theta naught. It's my LRT, critical region. Okay? Any question on this? Okay? If not, I'm going to moving forward, but only 5 minutes left. Okay, good. So we're talking about finding LRT right here. And then we're talking about power as well. Again, I want to remind you it's beta right here is not type 1, 2 error probability, as you will see. Okay? Then because under theta, right? Theta is under null space, under alternative space. I reject it, I do the right thing. So it's called power function. It's called power. Okay, doing the right thing. Then what is the case then? That means I rejected the null hypothesis. That means my delta x equals to 1. Okay? Then probability, binary variable, nothing but what? Take expectation. Under theta, it belongs to alternate space then. That's where this equation come from. Okay? Again, it's you do know type 1 error probability, you type 2 error probability is. I do want to talk about 2 tests. One test called size alpha test. Okay? The other one called label alpha test. It'll be confusing, trust me, but that's how we define it. Okay. The difference would be one is actually exactly equals to alpha. Okay. Although I didn't write power function right here, but keep in mind this guy right here, it's null space. That means under null, I reject it. Okay, type 1 error. Okay. Then it's alpha. Then label alpha test would be smaller than alpha, called label alpha test. Okay. I don't have time to derive in the whole power function. I will do that on Tuesday. Okay. Then if x1 to xn, if x1 to xn right here is normal theta, then sigma square. I do know sigma square. Okay, so it's a constant. Okay, so then I'm going to do testing. One is null hypothesis, theta smaller than theta 0, alternative theta bigger than theta 0. Okay, so say one will reject it by LRT. Okay, how to derive LRT right here? How? Okay, I don't have time to show that. As you can see, derive LRT taking a long time to derive it. So you might want to try it at home. To see, again, it's don't using that to derive LRT. Using the same way I did, finding some easy statistics, most likely MLE. Either it's bigger than C star or smaller than C star. Okay, you need to draw that equivalent graph to find it. Okay, then the easy way would be is what? Like I said, it's follow direction of the alternative space. It's follow direction of alternative hypothesis. That means eventually guessing would be this, bigger than C star. But you need to do the whole drill to find it, bigger than C star. It's okay. Then using that, you can draw a power function by definition under alternative space, or actually under overall space. I will show you on next Tuesday why it's actually under overall space. Under every theta in the space of overall space, I should say that more specifically. Then I reject it. It's my rejection region. Okay. Then right here it's because theta. Keep in mind theta not right here because of theta could be any point in perimeter space. So then true theta becomes theta right here. Okay, it's not theta, not theta. So it means when you do your normalization, you minus the true theta, then divided by standard deviation right here. Okay, I think it's 1:45 right now, so I think I want to dismiss the class. Okay, then again, there will be the past midterms posted, and then we'll have the discussion section on next Monday. You will see a bunch of LRTs. Okay, good. Any questions?
So you will send the Zoom URL for next Monday and Tuesday class later?
I'm sorry, say again?
So you will send the Zoom URL for next Monday and Tuesday class later?
Yes, I will. Yeah,
thank you.
Because I might be well set up a regular meetings, but because of the discussion section time will be varied, so I think I can send it point by point. I mean time by time.
Okay. Thanks.
Yes. Sure. Anything else? So how Ming say, did we miss power and possibly? I'm been writing too quick now. How Ming are still there?
Oh yeah.
Okay. One.
I think we missed the power
Yeah,
in
exactly.
when we
Yeah, I
calculate.
saw that. I saw that.
Yeah.
Yeah. Thank you. So that means this guy should be This guy should be n, right? So that means this guy is n right here. Right? I think so. So that means n, right? I think n. Yeah, be careful. So right here is what? Divided by n. Then divided by n. Okay. Thank you. Yeah, we do have n right here. So okay. Anything else?
When will you be posting the solutions for the practice exams?
Hold on. I cannot hear you. I cannot hear you because your voice look like floating. Could you say it again?
When will you be posting the practice exams? Next week?
I still cannot hear you, but I guess you're asking it, will I using the past exam of what? To do discussion?
No, I think he's asking when you'll post the solutions for the practice exams.
Solutions will be next Monday. I want you guys to try a little bit. So the past midterms we posted this afternoon, and the solution key will be posted after Monday's discussion. Making sense?
Yes, thank you.
Okay, good. Okay. Oh, why I cannot hear Hazel's voice then? Okay, I think it's internet connection. Everybody can hear you, but just not me can hear you. It's weird. Okay. So bye now. So you guys keep fighting. I know I'm boring right now, so stay home too much.
Thank you.
Yeah, sure. Bye.
Thank you.
I save it to P1. P6.
Professor, I forgot to ask, does midterm 2 include next Tuesday's lecture?
No, midterm will include only LRT.
Okay, just want to check.
Right.
Thanks.
So I think I talk about LRT too much. Don't you think?
I think
So
all right.
I suppose you guys are getting ready already. So I mean, I've been spending so much time at LRT, so it should be reasonable to cover LRT midterm.
Okay. Yeah.
But not about function for sure.
Okay.
Okay, sounds good.
Yeah. Thanks.
Okay. I'm going to stop the recording.